All right, the backside of this practice test. Okay, we have level 8, level 9, level 10. Now this is number 4, okay? Now, there are shortcuts here. I don't know if I take shortcuts all the time, but let's walk through each of these. We'll do the level 9 right here. Actually, let's do 8 and then 9. Okay, so I can see that instead of multiplying the 5 and the 15 together, I broke this one up to a 5 and a 3. And the reason why I did that is because I wanted to see all of them multiplying together to see if I can find a perfect square out of one of those. Because there's 2 5s, that's going to make a perfect square. It's going to make a square root of 25. And so I multiply those together, but I leave the 3 out. This variable has an even exponent, which is great because that means it's a perfect square. Whenever the exponent has an even exponent, whenever the variable has an even exponent, it's a perfect square. And so I did separate it though, just so we can see it. Now we have the square root of x squared, which simplifies to be just the x. That's why you see this x down here. You don't see the x inside the square root anymore. And then the 25 simplifies to the 5, so the 5 and the x get multiplied because they're both outside the square root, and the square root of 3 stays. All right, so that one's done. Over here, let's see. I actually do multiply this one out, but it's kind of funny because then I break it back up. So you almost don't want to multiply it out because you're just going to end up breaking it up again. And now I have a 3, a 5, and a 3. You'll notice there's 2 3s. That means there's a 9 times a 5. And so I wrote square root of 9 times the square root of 5. That would give me 45. And the square root of 9 simplifies to a 3. Yay! Now the x and the x to the 4th, I kept separate. I ended up not multiplying those together because I was just going to have to split them back up. X is raised to the 4th, and it has an even exponent, and that means it's a perfect square. So if I do the square root of x to the 4th, I get x squared. The square root of 9 is 3, and so the 3 and the x squared get multiplied together. This square root of 5 and this square root of x get multiplied to be a square root of 5x. All right, let's look at the next one. Now in this one, we're adding and subtracting terms that have square roots. If they don't have the same square root, you can't subtract them or add them together. Okay, but this one can be simplified. I know from experience that the square root of 25 divides 50. If I multiply 25 by 2, I get 50. And the square root of 25 is a perfect square. So that becomes a 5, which is why you see a 5 right here. And then you see a square root of 2. And now, oh, what a coinkydink. They're both square root of 2. That means I can combine them. So there's 8 over here, there's 5 over here, and we're subtracting, which means we're going to have 3 square root of 2's left over. Okay, and that's pretty much the same for both of these. Now, whenever you have a negative in front, make sure you put a 1 there so you know that there's a negative 1. Both of these need to get simplified, which I show you how to do right here. They both simplify down to a square roots of 3, and then you combine them to get negative 11. All right, last one, and I'm going to do level 10 on this one. Now, the goal is to get this square root alone. Okay, so we're going to get this square root alone first. That means we got to get rid of this 3 and this 2. So I like to get rid of the addition and subtraction first before I start trying to get rid of the multiplication and division. So the opposite of minus 3 is plus 3. So I add 3 to both sides, and I get an 8 on the right side, and now no more 3, okay? Now to get rid of this 2, I have to divide by 2, because 2 divided by 2 is 1. That's what I want. And I divide the other side by 2, and I have 4. Okay, now I have a square root, x minus 5 equals 4. To get rid of this square root, we're going to square this side. And we have to do the same thing to the other side. Remember, whatever you do to one side, you have to do to the other. When I square this side, the square root and the squared cancel out together because they're opposites, and I'm left with x minus 5. On this side over here, 4 squared is 16, and now I just have to add 5 to both sides to finish this off. Now, you might be wondering how come there's no plus or minus, and that's because we squared. We didn't square root. Only when you square root do you get pluses and minuses. All right, so when I add 5 to both sides, 16 and 5 is 21, and I'm finished. And if you wanted a cheat, actually it's not really a cheat, but if you want to make sure your answer is right, you can take that and plug it back in and see if it works.